So linear measures. First off, we have the Common Core Standard. Basically, if you read through that, all this stuff is done. In grade 2, they begin measuring things. And then in grade 3, liquid volumes and masses. In grade 4, they talk about area formulas. And also they do volumes and volume formulas for prisms in grade 5. Real world problems in grade 6 with area, surface area, and volume. Circumference in grade 7 with volume, and Pythagorean in grade 8. So we're going to do all those things to hopefully make you super comfortable so you'll be able to guide other folks in these matters. So the English system is a lousy system. The English system has been around for a long time. And it was in different places. It was in England, obviously. That's why it's called the English system. It started in England. And the English system is so bad that the English have left it behind. And only we still claim it. You know, we're the only major economic power in the world that still uses the English system. So the English system, when it first came out, I don't know if you've heard of it before, but a foot was like your foot. That's why they call it a foot. Of course, everybody's feet are a little different, huh? That's a problem, right? That became a problem. But that was originally, your foot was like the length of your foot. And a yard was from the tip of your nose to the end of your finger. So if you extended your hand into your finger, tip of your nose into your finger, that was a yard. Of course, that's different for everybody. And it, for a while, was defined as the King of England. Well, however, from the tip of his nose up to the point, And then when a new king came in power, suddenly the yard changed. So the price for fabric, for a yard of fabric, had to shift throughout the nation because now the yard was a different length. It was a big mess. And so what we have, they eventually standardized it in 1893. And so now a yard is 3 feet. A foot is 12 inches. You familiar with those? Remember those? And then one probably less familiar is a mile is 5,280 feet. No need to memorize any of those. You put them right on your card for the next exam. Let's go on to the metric system. Far better. So the United States is the only major industrial nation in the world that uses the English system. America is converting more and more to the metric system. Most science stuff is done in the metric system, even in America. So the metric system, probably know the basics of it. Meters, and then as you get bigger, decameters, hectometers, and kilometers. So a kilometer is 1,000 meters. So notice the metric system doesn't have any 12s or 3s. It's all about 10s. 10, 100,000. Like our base system is 10. That's why metric is so nice. They made the measurement system fit our base system, right? You guys know from Math 10A, we have a base 10 number system, don't we? Decimal. Des means 10. Decade is 10 years, right? We have a decimal number system, a base 10 number system. So when they made the metric system, they said, why don't we just make the measuring system fit our number system? Make the measuring system be all about 10, like our number system is all about 10. It was a beautiful fit, hand in glove. And you'll see that things we do in the metrics world, calculations, are super easy. All we'll need to do is move the decimal. Whereas things we do in English, when we convert them, we need to deal with fractions and canceling denominators and all that, because it's not a nice fit with a base 10 number system. So then smaller than meter is decimeter, centimeter, and millimeter. A millimeter is 1/1000th, 0.001 meters. All right, this thing is like the golden rule of the metric system. You'll love this thing. It'll make life so easy to convert. It's just a nice little thing. I'll write it out for you in a minute when we dive into the homework. But it's basically going to show us the steps for converting. It's basically going to tell us how to move the decimal to convert in metrics. All right, let's dive into the homework, that brief introduction. So we're starting with English. So 92 inches is how many yards? 92 inches. So let's start with that. 92 inches is how many yards? So I don't know if you've learned to convert units at all. I learned to convert units not in any math class, but when I was a brand new freshman at the local junior college up in Sacramento, where I grew up, and in chemistry 3A. Have you taken basic chemistry? It was I didn't take any chemistry in high school. It was like my first intro chemistry class. Chem 3A, and Mr. McCallum he was close to retiring back when I was a freshman in high school. So it's been a while. I'm a freshman in college. He showed us how to convert units from any kind of units to any kind of units, because you do a lot of that in chemistry. And I didn't get it at first. And and then right after the exam, then I got it. That's a little bit too late, at least for the first exam. But literally, he was going over the first exam in which we had to convert a ton of units. He was going over that exam, and as he was going over it, I was like, oh, I see now. I was doing it crazy hard. So hopefully I can give that to you right now. Unit conversion is super easy if you see the idea. Here's what it is. First off, make that look like a fraction. Just put it over 1. Just so it looks like a fraction. We haven't changed anything. And then here's the deal. You want to go from inches to yards. See, I used to sit around and think, okay, yards are bigger than inches, so if you're going to multiply, no, going to divide, because I mean, you don't need to think that hard. Here's all you need to do. Let the words, let the units guide you. Words first, numbers second. That's what I wasn't getting. So here you go. So you're going to do another fraction. Oh, and by the way, first, notice I put down where we're starting, inches, and where we need to end up, yards. So that's always what you want to do. Put where you're starting and where you want to end up. Starting with inches, got to get to yards. That's what they're asking of me in part A there. Okay, so it's going to be fraction, fraction, fraction in the English system. So how do you know what to do for the next fraction? Well, you have inches up here in the top, and you want inches to cancel. Don't worry about numbers right now. Just focus on the words. That's what I wasn't getting. So where do I have to put the word inches, or the unit inches, if I want the word inches to cancel? On the bottom, yeah. No numbers yet. That's what I didn't get. I kept trying to put the numbers in and think, how does he know where the numbers? I wasn't getting that he was doing the words first. So you think, well, yeah, inches have to go down there. Why? Because I want them to cancel. That was news to me in chemistry, that you can cancel words just like you do numbers. But you totally can. You cross-cancel the units. Okay, great. So, well, how do you know what goes in the top? Again, no numbers yet. First, the words. Well, let's just go back to our little conversion. And what do we have? We have inches, right? I have inches right here. Let's go back to our little conversion chart. What do we have a connection? Where do we see inches? Right there, 12 inches. And what does it connect to? 1 foot. So I used to try to, when I was first to try to think really hard and go, okay, well, there's 12 inches in a foot, and there's 3 feet in every yard. So how many? No. You don't need to think that hard. Just take what they give you without any deep thinking. 12 inches is 1 foot, right? I'm not going to yards yet. We'll do that later. 12 inches is 1 foot. So go back here and say, okay, 12 inches is 1 foot. I just took what they gave me. I didn't think hard or do any mental calculation. Just 12 inches is 1 foot. Now, if I stop the problem right now, inches have canceled out, and I'm in feet. So I'm almost there, but I want to get to yards, don't I? So I need another step, another fraction. The next fraction, how do you do the next fraction? Same way you did the last one. You start by what you want to get rid of. What do I want to get rid of? Feet. So where are feet going to go? On the bottom, so they cancel. So again, start with the units, not the numbers. I kept thinking, how did he know where the number goes? Well, because he was doing the words first. The words first. So 12, feet cancel. Now, what can I go to from feet easily? What do I know? Let's go back to the chart. Feet, 3 feet is 1 yard, says the chart. So 3 feet, that's how I know where the 3 goes. I already got the feet there, huh? 3 feet, 1 yard. If I stop the problem right now, inches cross-cancel, feet cross-cancel, and yards are left. Perfect. That's what I want. I want yards, okay? So what does that mean we do? Well, normally, this problem's kind of weird. I wish they wouldn't do it weird. In a minute, we'll just use our calculator and decimal it. Normally, you would just take your calculator and you would just go 92 divided by 12 divided by 3. Anything under the bar is divided. Anything in the top of the bar is multiplied, and we would get a decimal. Now, on this particular problem, for some weird reason, they want a fraction. So I can't actually just hit the buttons and get a decimal. But we will pretty much from here on out. It'll all just be hitting the buttons, getting a decimal. So instead of doing that, I have to put the 12 and the 3 on the bottom and like work out the fraction, which is kind of weird. Normally, you would just divide on your calculator. So they're telling me they want a fraction answer, so I'm just taking the numbers as they were. What? The 92 was on the top, and the 12 and the 3 were on the bottom. So that's 92 over 36, right? 3 times 12. And then you just have to reduce that fraction. So how do we reduce it? Just divide by 2, I guess. We're going to get, what's that, 46 over 18. Divide by 2 again. And we'll get, what's that, 23 over 9. Boom. There we go. We'll make it a mixed number. So remember how to make that a mixed number? You just divide 9 into 23, right? Because 9 goes into 23. 2 times, that's 18, 5. So it's 2 and 5 ninths. 2 and 5 ninths. So they're being really painful on this problem. Normally you just hit the buttons on the calculator and get a decimal. So they want you to take that 23 ninths, long divided, bottom into the top, change it to a mixed number. The mixed number would be 2, right? You take the answer on the top, 2, and then the bottom goes over the left, 2 and 5 ninths on that. Questions on that? Okay, so yards go down below. Yards will cancel. Now, what can we, right, we're always motivated by what we want to cancel out. So we do that first. No numbers first, just the words first. What can we do easily from yards? We go back to the chart, What does yards connect to back here? 1 yard is 3 feet, isn't it? So we just go, okay, we'll just do that. 1 yard. So 1 yard, 3 feet. Makes sense there? 1 yard, 3 feet. And then are we done right now? How do you know when you're done? Well, if we stop right now, what unit do we have left? Feet. I want inches in the end, right? So always have your goal before you. You want inches in the end, so we got to take another step. So I'm going to multiply. And what am I going to do first on this next fraction, next step? Feet on the bottom. Yeah, so you start with the words by what you want to cancel. That's what I didn't get till right after the test. So feet down there cancels. And then what can we go to easily from feet? Inches. And we know that connection, right? What's the connection between feet and inches? Yeah, 12 inches and 1 foot. See how I know where the 12 goes? Because I've already written inches in the top, huh? That's what I wasn't getting. I said, well, how did he know that 12 goes in the top or the bottom? Because I was trying to start with the numbers. But if you start with the words, then you know, well, 12 inches, 1 foot. You know where they go, huh? The words lead the numbers. That's what I wasn't getting. The words go first, and then the numbers follow naturally. And we're where we want to be, right? Because yards are canceling, feet are canceling. We're in inches. Okay, now those, what are we going to do on our calculator? Well, those are both in the top. On the last problem, the other fraction numbers were in denominators, weren't they? So that was divide. Things that under the bar divide, things at the top you multiply, huh? So I'm just going to simply multiply by 3, multiply by 2. Just hit the buttons on your calculator and we'll get some big number, huh? I'm getting 16,200 on that one. And that is inches. And there we go. Okay, so try part D. We'll skip C. It's the same thing. Try part D. 468 inches, and they want you to convert it to feet. So you know the deal. Put it over 1, make it look like a fraction. And you know, first thing, inches have to go on the bottom, don't they? Because you want inches to cancel. So inches go on the bottom. We're motivated by what we want to cancel out. Bye-bye inches. And what can we go to? We want to get to feet. Can we go to feet from here easily? Yeah. What do we know? So I've already got the words, the units written down. And so I know the connection. We know the connection, right? What's the connection? 12 inches in 1 foot. See how I know where the 12 goes? That's what kept confusing me when he was doing stuff on the board. I remember going, how did he know the 12 goes in the bottom instead of the top? Well, it's because the words are there first. So anyway, so what am I, and the inches are canceling out. We're in feet. That's where we wanted to be. So we're done. We don't need another fraction, right? We're already where we wanted to be, feet. So, okay, so what am I going to do on my calculator then? Am I going to multiply or divide? Divide because the 12's on the bottom. Makes sense? So just divide. And what'd you guys say, 39, did I hear? 39 feet. Makes sense? So you don't need to think hard about multiply, divide. You just let the units guide you. They'll guide you right to the answer. And that's going to work in the next, and when we get to even harder ones in a bit. All right, I'm going to move on. Questions on that one? All right, to number 2. We're going to do now metric conversion. This is actually way easier. I like this even better. Metric conversion. Now, you don't even need fractions. So let me grab, they're going to want us to convert like 31 centimeters. They're going to want me to change it to meters and then to millimeters and then let me then take this one and convert. So basically they're going to give you one entry in each row and want you to convert to the other 2 types of units is basically the deal. They're going to give you, like on that first one, they're giving us centimeters, 31 centimeters. They want us to change 31 centimeters to meters and millimeters. And then the second one, height of a woman, 1.47 meters, want us to change that to centimeters and millimeters, etc. Just practice converting within the metric world. Well, it's really easy, if we go back here, to this golden rule of the metric system. So you're going to love this thing. You put this on your 3x5 card. It makes it so easy. So I'm going to basically copy that down. If I can remember deci, centi, millis. Let me go back here. So right in the middle here is a meter. And then this will be deci, centi, milli. So deci, centi, milli. And then the other way, 1, 2, 3. This is deca, hecto, kilo. So basically this is meters, decimeter, centimeter, millimeter. This way is decameter, it's abbreviated DAM, hectometer, so it doesn't confuse with decimeter, and kilometer. Okay, so what did I do? I just basically grabbed this, right? The meter is the base one in the middle, and I just did the 3 names to the right and the 3 names to the left. I'm not showing the stairs, but that is nice. So I just basically simply copied down that little table that they gave us that you'll have on your 3x5 card. And now, to convert anything within the metric system is so easy because you just start with what they gave you, 31 centimeters. I'll start right here. 31 centimeters. And they want me to convert it, first off, to meters. So if I'm going to convert from centimeters to meters, here's what I do. I just look at the chart and I go, okay, if you're at centimeters and you want to get back to meters, that's 2 jumps to the left, isn't it? From centimeters back to meters is just 2 jumps left. So then that's exactly what you do with the decimal point. Now, where's the decimal on the 31 right now? I don't see a decimal. So where's the decimal? If somebody said the price on that is $31 and they didn't put a decimal, they don't mean the decimal right there, do they? That's not 31. I don't know if you can see my decimal. They don't mean that, do they? That wouldn't be $31. So where's the decimal really? It's at the end, huh? If somebody doesn't put in the decimal, you know where the decimal really goes. It goes at the end. So, okay, so it's at the end. So then it's 31 with a decimal at the end, centimeters. But we're jumping back 2 steps to change to meters. So then you grab that decimal and do the same thing. You just go back 2 steps. So it's 0.31 meters. So 0.31 meters is exactly the same as 31 centimeters. And now let's go to millimeters. If we're going to go to millimeters, that's 1 jump. From centimeters to millimeters is 1 jump to the right. So I take that 31. Let me put it back to where it was. Take that 31, which started with the decimal at the end. And I'm going to need to go 1 to the right to go to millimeters. And so what's that going to happen? What happens when you jump beyond the edge, when the decimal goes beyond the edge of the number? Left or right? What happens? Zeros come in, don't they? So 1 to the right, 310. Done with part A. Does that make sense? You just find out how many jumps left or right and just move the decimal that many spots. left or right. No fractions needed because it's base 10 measuring system fitting base 10, our base 10 number system, hand in glove. Remember from Math 10a, we have a base 10 number system, don't we? And metric is a base 10 measuring system. Let's try the next one. How about the height of a woman, 1.47 meters. 1.47 meters. Meter's about a yard, so she's about 1.5 yards tall. So it's about average. 1.5 yards tall. So start with that one. And we're going to 1.47 meters, so start right here. 1.47 meters. And first off, you're going to change to centimeters. How many centimeters tall is she? So if I go from meters to centimeters, that's 2 jumps to the right, isn't it? From meters to centimeters. So I'm going to grab that decimal and go 2 jumps to the right. So 147. You don't even need to show the decimal. The decimal's understood to be at the end. It's like a period in a sentence, right? If they don't put the period on, you know where it goes. It's at the end. Same thing for the decimal. How about millimeters? Can you change to how many millimeters tall is she? So again, 1.47 meters, 1, 2, 3 jumps to the right to get all the way to millimeters. So grab the decimal, go 1, 2, and you're to the edge, 3. So that's going to bring in a 0, isn't it? 1470. Remember, when you go beyond the edge, that starts bringing in zeros. So 3 jumps to the right, goes 1 beyond the edge, brings in a 0. So she's 1470 millimeters tall, which is the same as 140 centimeters tall, which is the same as 1.47 meters tall. Questions so far? Want to try the film strip? The width of the film strip, 35 millimeters. So start with that 35 millimeters. And change that one. So we start over here, 35 millimeters. Decimal understood to be at the end when it's not shown. And jump back to centimeters and then all the way back to meters. And move the decimal the same amount. So from starting with millimeters, jumping back to centimeters is 1 jump to the left. So that'll be 3.5. And to get all the way back to meters is 3 jumps to the left. So that's going to be 0.035, isn't it? Again, when you go beyond the edge, left or right, that brings in 0. So when I move that decimal 3 places to the left, I got a 0.035. Isn't that easier than English? You don't have to use fractions because it fits. It was designed to fit with a base 10 number system. That's why the metric system is superior. It's easy to convert units. It's designed to fit with our number system. All right, I'm going to skip the last 2 because we got harder things coming. We good there? Questions I can answer, though? More. This is conversion within the metric system also. Why don't we go ahead and do, just part C? Here, let's do part C. So 5 kilometers, and we want to change it to meters. Again, we're not going to do fractions, because in the metric system, you just move decimals. You don't need to mess with fractions. So take that 5 kilometers. Can you change that to meters? So you can look back at the chart here. I want to go kilometers to meters, right? Choose the same exact chart. So over here, 5 kilometers. And they're asking us to change that to meters. So the kilometer goes 1, 2, 3 jumps to the right to get to meters, right? 3 jumps to the right. So that means I need to take the decimal. Where's the decimal on the 5 right now? I don't see a decimal. It's at the end, huh? Somebody says the price is $5, you know it's 5.00, huh? There's really a decimal right there currently. And then I just move that decimal 3 places to the right. So every one of those is going to add a 0. It's going to be 5,000 meters, isn't it? Does that make sense? If I take that 5 point and I go 1, 2, 3 to the right, those all bring in zeros. Whenever you jump beyond the edge of a number, it brings in zeros. So 3 jumps to the right, 5,000 meters. So just go back and go, okay, this is 5,000 meters. 5 kilometers is 5,000 meters. Questions I can answer on that one? So making sense. So I'm going to skip those other parts of number 3 here, because they're the same thing. Just converting within the metric system, just move the decimal right or left. And let's get on to number 4, which is a little bit different. Anybody remember the circumference? First off, what is the circumference of a circle? It's how far around the outer edge. Yeah. Right? So it's not the area in the middle. The area in the middle, there's circumference. The area in the middle formula, you probably know, that one's more popular, pi r squared. That's area inside. We'll get to that one next week. We'll do a bunch with that. Pi r squared. That's area inside. We're just talking about around the outer edge right now, circumference. Anybody know that formula? That one's more rare.
C equals 2 pi r.
2 pi r. 2 pi r. So it uses the same 3 pieces, pi r, but the 2 comes out front instead of being on power. We'll talk more about that next week. But for now, we just need that formula. Circumference equals 2 pi r. Circumference equals 2 pi r. So then for these questions, like for this part A, they're saying, so circumference, I'm just going to write circumference equals 2 pi r. And they're telling me, okay, we got this circle here, and its circumference is 20 pi. Find the radius, find r. So how am I going to do that? Well, I'm going to take the 20 pi, and I'm simply going to plug it in for the word circumference, because they're telling me the circumference is 20 pi. The circumference equals 20 pi. So this means 20 pi equals 2 pi r. Good so far? So you just plug 20 pi in for the word circumference. And then, what do they want me to find? What am I trying to solve for? R, right? So I have a little equation, and I need to solve that for r. How do we solve there for r? How do we get our r's over here saying, I want to be alone. Get rid of this 2 pi, please, so that I can be alone. So we divide, because that 2 pi is multiplied, huh? Divide by 2 pi, and the 2 and the pi cancel. Perfect. Now, okay, so how do you work that out on the left side? What happens over there? What does 20 pi over 2 pi do? What do the pi's do? They cancel. And 20 divided by 2? Just 10. And that's our answer. Oh, and the units, they just stay the same. We're not changing units. It's just centimeters. So the radius would have to be 10. See how we did that? We just took the circumference equals 2 pi r formula, plugged in the circumference they gave us, and divided by 2 pi to get r. Let's try part B. It's going to be very similar. So again, circumference equals 2 pi r. So grab the circumference. This time it's just 10. Don't worry about the meters. We'll just put the units at the end. Just grab the 10. There's no pi this time, is there? There's just 10. Plug that in for the word circumference, 10, and then solve for r. You're going to end up having a pi in the answer. They want you to leave the pi in the answer. So what's the circumference? 10 equals 2 pi r. Now how do I solve that little equation for r? Same way I did last time. Divide by the 2 pi, right? Divide by the 2, and the 2 and the pi cancel. So r's alone. But this time, on the left side, I can't cancel pi's, can I? That pi is just going to stay on the bottom, isn't it? Because there's nothing to cancel it. So, but I can cancel the numbers. What's 10 divided by 2? 5 there, right? So the 2 goes into the 10 5 times. So we end up with the 5 on the top and the pi on the bottom, and they need to stay that way, and that's our answer. Does that make sense? See how the 5 is on the top because the bigger number was on the top, right? The 10. 2 went into the 10. 5 times on the top, and the pi must stay on the bottom. Sometimes it's an easy mistake to make to say, well, the answer is 5 pi, but that's not the same, is it? Because that would mean the pi is on the top, and that's different. They want us just to leave the pi. And when you type it into Math Excel, a little palette will open up, and they'll give you pi as an option. So you'll be able to type that in. So it's 5 over pi. And the units just stay the same. We're not messing with units here. Just meters. It started with meters. It's still meters. All of that. Questions on that? That makes sense? Just using the circumference formula. Dividing by 2 pi to solve for r. The next one's kind of similar, number 5. They're giving me diameter and radius, and they want me to find circumference. So I again use the circumference formula. Circumference is 2 pi r. And then on part A, they're telling me the diameter. Now let me draw a little picture down here. Remember diameter? What's the diameter of a circle? Diameter is all the way across, huh? Yeah, radius is just halfway. Right, you guys are thinking right. And diameter is all the way. Yeah, so radius is half a diameter, huh? Yeah, radius is just from the middle to the edge. Diameter is all the way across. So yeah, so I've got to take that diameter they gave me, 17, and divide it by 2. What is that, 8.5? So that'll be the radius of 8.5. So because they gave me the diameter, 17, all the way across. If I divide it by 2, I get the radius, because that's just halfway across, middle to the edge, 8.5. And now I can just grab that and plug it in there for r. They want me to find the circumference, so I can do that. So it's going to be 2 times pi times 8.5. And they want me to leave the pi. So when you multiply that together on part A, you just leave the pi and you just multiply the two numbers. 2 times 8.5. It's going to go back to 17. The answer is 17 pi. I just did 2 times 8.5. So the circumference is 17 pi, and they want the units just the same, feet. Just that doesn't change. So do you see what happened there? I just used the circumference formula, 2 pi r, but I had to first find the r. I took the diameter, divided it by 2, 17 divided by 2, got the radius, 8.5, plugged that in for r, and then 2 times pi times r, multiply the two numbers back to 17 again. 17 pi is the circumference. So what about part B? Can you do part B real quick? I'm going to go around because this is the big one, and we've only got like 6 minutes left here. All right. Have you heard of Mach speed? What is Mach speed? What if a plane flies at Mach 2.3? What does that mean? What is Mach 2? Twice the speed of sound. So the speed of sound. How fast does sound travel? You're all hearing my voice. It's coming out of my mouth and traveling to your ears pretty quickly, right? But, sound doesn't travel as fast as light. Have you experienced that? I'm tempted to do a whole physics thing. I love physics. I think it's very interesting. But you probably experienced that, right? You ever seen something far away and you see it before you hear it? Yeah. Something far, far away, and you'll see it happen. It's always baseball for me. I'm always walking up to one of my kids' baseball games, and they're far away, and I'll see the batter hit the ball, and I'll see it, and then I'll hear the crack of the bat come to my ears. So there's probably it's the one that always sticks in my mind. So
it's similar to like thunder and lightning.
Oh yeah, thunder and lightning. That's right. You see the flash before you hear the thunder, right? So it happened, and the light got to our eyes before the sound traveled to us. How fast does sound travel? Well, approximately 344 meters every second. A meter is about a yard. So a football field is 100 yards, right? 100 yards in a football field. That's about 100 meters. So 300 meters would be about three football fields. So 344 is about 3.5, right? About 350. That's about 3.5 football fields every second, just to give you a feel. Sound travels 3.5 football fields every second. So then if a plane is traveling Mach 2, it's traveling twice that fast. If a plane is traveling Mach 2.3, it's traveling 2.3 times that speed. So they want me to take Mach 2.3 and change it to kilometers per hour. Let's see if we can get through part A. So let's do part A here on number 6. Part A, Mach 2.3, speed of sound, 344 meters per hour. So that means I'm going to start with 2.3 times the speed of sound.
I thought it was meters per second.
Oh, meters per second. Thank you. Not an hour. That'd be much slower. We wouldn't be hearing anything very often. Thank you. Meters per 1 second. See how I changed it to a fraction right away? 344 meters per over 1 second. That's what that means, huh? That's why it's a fraction. It's meters per second. So the sound travels 344 meters per second, and the plane's going 2.3 times that fast. Okay, and then what do they want in the end? In the end, they want me to convert it to kilometers per hour, I think. Wasn't that it? Yeah, kilometers per hour. So it's a fancy conversion problem. We've only got 2 minutes, so I'm going to have to do it kind of quick. So first off, put the 2.3 over 1. Make it look like a fraction. And now, remember, there's 2 main ideas. Hang with me for these 2.5 minutes here. There's 2 main ideas you need to keep straight in your mind. Converting in metrics is just moving a decimal. No fractions needed. Well, then why am I doing fractions? Because I've got seconds and hours, and I got to convert time. That does require fractions. So I'm only doing the fractions for the time part of it. The kilometers and meters, I'll do at the end by just moving the decimal. That's no problem. So right now, my focus is just the time. I'm just looking at seconds and saying, I got to make you hours. I don't care about kilometers and meters. I can just move a decimal at the end. That's easy. So, okay, so how do I make seconds then become hours? Well, what did we talk about? Converting units. Your next fraction, you start with the words, and how do you know what words? Whatever will cancel out what you're trying to get rid of. What am I trying to get rid of right now? Seconds. Where are seconds right now? On the bottom. That's different. They're on the bottom. And if I want to get rid of something on the bottom, where do I need to put seconds on the next fraction? On the top. And then seconds will cancel, you see. See how I know where to put them? Now, what? Okay, great. I see seconds are up there. No numbers yet. Remember the words first. What am I going to go to? We need to go to hours. How many seconds in an hour? I don't know. If you know, great. But you don't have to think that hard. That's what I was trying to do in that chemistry class. If you know it, great. You can just do it in 1 step. But hey, let's just make it easy. What do you know easily off the top of your mind? Seconds to what? Minutes, yeah. So let's just go to minutes. And what's the connection? 60 seconds, 1 minute. 60 seconds, 1 minute. So we'll just do that. Now, if we stop right now, we're in minutes. We don't want minutes, so we need another fraction. Where's minutes going to go? It's going to go in the top because we want to get rid of minutes, don't we? So we want to get rid of minutes. So, and then what's going to go in the bottom there? What do we know easily with minutes? Hours, huh? And what's the connection? 60 minutes, 1 hour. So if I stop the problem right now, what units am I in? What's left standing? Minutes have canceled. Seconds have canceled. What's left? Meters per hour. So let's use our calculator right now. Take 2.3 times 344 times 60 times 60. They're all in the top. If they were under the bar, I would divide. But they're all in the top. So I just multiply them. And I'm getting a giant number. 284 8320. You getting that? And that is what units again? Meters per hour. That's meters per 1 hour. And what did they want me to do in the very end? Go to what? Kilometers. Now, how do you change meters? Now it's just moving the decimal, huh? The decimal's right here now. How do you change meters to kilometers? If you go back to our charts, meters back to kilometers, from meters to goes 1, 2, 3 to the left to get to kilometers. 1, 2, 3 left. So I just go 3 left. Take that decimal. 1, 2, 3 left. So it's 2848.320 kilometers per hour. There it is. All right, I'll try to do the other two for you and put it on YouTube. Okay, so there's our answer on that one. Let's try part B now. Just coming back to part B. They're telling us Mach 4.4, go to meters per second. So part B, so 6B, Mach 4.4 to meters per second. So, okay, so Mach 4.4 means 4.4 times the speed of sound. What's the speed of sound? 344 meters per 1 second, right? Right there. Meters per 1 second. That's the speed of sound. And so this is the speed of sound here. Okay. And so, and we want to go to meters per second in the end. Well, this is super convenient because we're already in those units. It's already meters per second, so we don't have to convert any units. Just multiply. Just multiply 4.4 times 344, and I'm getting 1513.6, and it's already in meters per second. And so we're done with part B that easily. And now part C. Oh, they want to round to the nearest whole number. I didn't notice that. So, whole number, round to the nearest whole number. So this one should have been 2848 kilometers per hour. And this one should be 1514 meters per second. And now on part C, they say 3,000 kilometers per hour as a Mach number. That's tricky. 3,000 kilometers per hour as a Mach number. Okay, let's go back to it. So part C, 3,000 kilometers per 1 hour. Well, as a Mach number. Now, what's a Mach number? Remember, a Mach number is the speed of sound. 1 Mach is the speed of sound. Remember the speed of sound right here? 344 meters per 1 second. So basically, I need to take this kilometers per hour and change it to meters per second, because that's the units of Mach, because they want me to figure out how many Mach speeds it is. So let's do it. So first off, you've got to use the fractions to change the time. Remember, we don't need fractions to change the metrics. Kilometers to meters, that's just moving a decimal, no problem. But to change the time, hours to seconds, we need fractions. So hours down below, put hours in the top. And then hours will cross-cancel. What can you go easily? What do hours connect easily to? Minutes, right? We don't need to think hard here. 60 minutes in 1 hour. Right now, hours cancel out, and we have minutes left, right? Hours are gone, but minutes are left. We don't want minutes. We want seconds in the end. So how do we get rid of minutes? Put them in the top. Minutes are gone. What can we connect easily with minutes? Seconds, right? 60 seconds, 1 minute. Minutes are canceled. If we stop the problem right now, we're in kilometers per second. We want meters per second, so that's pretty close. If I'm going to go ahead and use my calculator, calculate this, and then I can just move a decimal. So I'm going to take 3,000 divided by 60 divided by 60, because the 60s are underneath the bar. Do you see that? 60s down here, down here. Things underneath the bar, we divide. Things in the top, we multiply. So if I divide by 60 twice, I'm getting 0.8 with a bunch of 3's. And what is the units on that? I'm going to put a whole bunch of 3's here. Remember what's left? Kilometers per second. That's kilometers per second. Remember, I want to go to meters per second. So now, how do we change those kilometers per second to meters per second? The seconds are good. I'm not messing with time. I'm just changing kilometers to meters. Well, let's go back to our chart to change kilometers. I'll go back all the way back to this thing here. To change kilometers to meters, 1, 2, 3 jumps to the right. Or you could use this chart here. Kilometers to meters, 1, 2, 3 jumps to the right from kilometers to meters. So 3 jumps to the right. So I'm going to take this decimal and go 1, 2, 3. So it's 833 point, and then, 3's forever. Now that's meters per second. So I went 3 jumps to the right. 833, right? The decimal was before the 8, went 3 jumps to the right. 833.3333 meters per second. Okay. Now they're saying, what Mach number is that? In other words, that equals what times 344? What number times? In other words, it's what times the Mach speed. It's how many Machs. That's what they're asking. This speed, we started with 3,000 kilometers per hour and we changed it to 833.333 meters per second. And that's equal to what times 344 meters per second? We got them both into meters per second, so they're in the same units. So 833.333 equals what number? This is like an x. Equals x times 344. What times the speed of sound? What times 344? What's the Mach number? The Mach number is what you multiply by the speed of sound. Like up here, Mach 4.4 meant 4.4 times the speed of sound. So what Mach number, let's make it a big M. What Mach number times the speed of sound will equal our 833.333 meters per second? Solve for M. How do we solve for M there? Divide by the 344. Divide by 344. These cancel and you'll get your Mach number. So just divide by 344. I'm getting a Mach number of 2.422. Do they want how far they want it rounded there? They say 2 decimal places on that one. So 2.4, we'll round it to 2.42. It's 2.42 Mach times the speed of sound. There we go on that one. All right, and then lastly, number 7. I think this will be easy for you. Basically, it's asking why in a race around a track, why do they start this person behind that person? Well, I mean the other way around, sorry. So they're running around this track, and they're running this. This guy's going to run this way. This guy's going to run this way. Why does the inside lane start backwards? Well, it's because the outer lane has further to go every time around the outer circle, right? Like if you go like this, and you go all the way, getting a little off there, go around the outer circle, that's a bigger circle around than this is. This inside is shorter, so he doesn't have as far to go, so they back him up a little bit because he doesn't have as far to go. So it really makes them equal. The guy on the outside lane here, he has further to go, so he gets a head start to make the total distance equal. That's what they're saying in B. The outer curve has a greater radius and correspondingly greater distance, the arc length, to run. So the outer lane has further to run. To compensate for the extra distance for the outer lane, the runner in the outer lane is given an apparent head start, but it's not a real head start. It really makes their distance around equal. That's what's going on there.